everyone. So today we're going to talk about chemical equations, how the structure it is, and why chemical equations are important. Before we even talk about the structure of it, we do need to explain the why. Why does this happen? Why does this occur? What's the point of it? So the point of it really goes down to the law of conservation of matter. The law of conservation of matter states that matter is not created nor destroyed. So in other words, how much we end up with is going to equal the amount of stuff that we start with. So the amount of stuff we have at the beginning needs to equal the amount of stuff that we have at the end. This is really important because if we had an instance where we had more stuff than what we started with, we'd end up having a surplus or too much stuff in the world of a certain compound or whatever that we make. If we happen to have an instance where we ended up having less stuff than we started with, then we'd eventually start running out of materials and resources of particular items. So because of that, once again, everything has a finite amount and everything will get created, and then things can also be used to create those certain things back again. And we always have the same amounts of stuff. So once again, the amount of reactants that we have on the left side is going to be equal to the amount of stuff on the right side, which is the products. Okay? And just to show that idea, we just have a balance on the side. Once again, the balance has to be equal. And by being equal, it conserves the law of conservation of matter, and that's kind of what is shown here with the chemical equations. So when we start, first thing we need to go over is the idea of reactants. Reactants are basically everything that is to the left of this red arrow here. So everything here in blue, those are called our reactants. It shows what we started out with. So in every chemical equation, whenever we do a reaction with certain items to make new things, we always have to start with something. And for this specific example, we happen to be starting with carbon dioxide and water, which we have two pictures shown at the bottom right here below. Over here onto the green side, we have products. Products are basically everything to the right side of the arrow. So everything to the right here, those are our products. It shows us what we ended up with. And another way to say it is basically what you end up creating. So by putting carbon dioxide and water together, you will make a reaction where you end up with sugar and oxygen. If you're curious, this is also the example of a photosynthesis reaction. Yield. Yield is the arrow in the center. In science, just to clarify, yield means to create, to make, or produce. I understand that for some of us, we see the yield sign outside on the streets. That basically means to slow down, but in science specifically, it means to make or produce. You'll notice that this yield sign is pointing to the right. So basically, the yield sign points to all the products that are created, which is on the right side. Once again, it's an arrow sign. It also separates reactants from the products. So basically, everything to the left of the arrow, that's the reactants. Everything to the right of the arrow, that's the products. And how do you know which one is from which? You just look for that arrow sign. That thing is the thing that separates the two things from each other. Okay. Also, for those of you who are confused, you can kind of think of it as an equal sign if it helps you. So basically what you're trying to do is that this is the equal sign here, and everything to the left here, that's how much stuff you have here, and everything to the right here is how much stuff over here. And just like how it is in a balance, you're trying to have equal amounts of stuff on both sides. So if it helps you to think of the arrow as an equal sign instead, to kind of help visualize that for you, that's perfectly fine with me. So once again, if that helps you out, we'll just change that. So once again, if it helps you, think of it as like an equal sign because you're trying to have equal amounts of stuff on either side. Okay? Alright, next part. So the other thing we need to go over are the subscripts. So subscripts are those small little numbers to the right. So let's just get that up there. Once again, small numbers to the right of elements. So for example, this 6, this 12, this 6, this 2, this 2, and that 2. Those are all examples of subscripts. They cannot be changed. The reason why these cannot be changed is because if you change it, you change drastically what you have. So for example, if you put H3O instead of H2O, this no longer becomes water. You now have hydronium, which is a completely different thing. If you happen to change this O2 to like O3, you're going to start having ozones and stuff like that. It changes the compound completely. So adjusting these subscripts are a big no-no. They cannot be changed. You're going to make different compounds completely. Okay? We're showing you a picture of a submarine because the word sub means below. So if it helps you, submarines are below the ocean. Sub means below. The subscripts are below the elements or the letters. So basically, because they're below, there, if it helps you to visualize it better, you got a submarine right there. Okay. Last but not least, we got coefficients. These are the numbers that we have here in black. They're the numbers that are in front of elements and compounds. The other thing that we need to point out and mention to you is that these are the only things that can be changed in the chemical equation. So you can't change subscripts, you can't change the elements and change the letters to something else. Not allowed to do that because, once again, just like with the subscripts, if you change the elements or letters, you get a completely different compound as a result. Okay? So once again, only these coefficients here in the front. So the 6 here, the 6 there, there's nothing here, and then the 6 there. These are the only things you're allowed to change in order to balance out the equation. Okay? So just to sum up, we have the law of conservation of matter. It tells us that matter is not created or destroyed. We have reactants. That's the left side of the arrow, and that's what you start with. We have products. That's the right side of the arrow. This is what you end up, or this is what you created as a result of the reaction. We have subscripts. We have yield. Once again, it basically means in science to make or produce, and the arrow points to the stuff that you have made. We have subscripts. These are the small numbers to the right of elements. These cannot be changed. And then last but not least, we have coefficients, the numbers in front of the compounds, and the only things that you're allowed to change in order to balance out a chemical equation.